Good morning, everyone. I am Professor Viral Panchal, Head of Computer Science and Engineering Department at SN Patel Institute of Technology and Research Center, Umrah, Bardoli. Today, our webinar topic is Enabling Collaborative Processing with Internet of Things for Industry 4.0. And our today's expert speaker is Dr. Saurabh Kumar. Good morning, sir.
Good
On
morning,
behalf
Viral
of,
sir.
on behalf of SN Patel Institute of Technology and Research Center, Umrah, and Vidyabhari Trust, I heartily welcome you, sir.
Thank you very much.
Okay, before beginning this session, I request Professor Uttam Mahajan to give the brief introduction about our today's expert speaker, Dr. Saurabh Kumar. Madam, now,
Very good morning to one and all. We are having an amazing speaker to explore this topic related to IoT and Industry 4.0, Dr. Saurabh Kumar Pandey. Sir is currently serving as an assistant professor in Department of Computer Science and Engineering at LNM Institute of Information Technology, Jaipur, Rajasthan. He has received his PhD degree in computer engineering from Sardar Vallabhbhai National Institute of Technology, Surat, Gujarat. He has been working on problems of optimizing deployment strategy and localization of nodes and events using IoT for post-disaster management. Sir has successfully published plenty of conference and journal papers with leading publication houses like ACM, IEEE, Springer, Elsevier, Oxford University Press in these fields. He has been an active researcher in the field of Internet of Things, collaborative data processing, multi-agent system, and wireless sensor networks. Recently, he was conferred with the 2019 Wilkes Award for the Best Paper runner-up by Oxford University Press for his novel work on localization of events for post-disaster management. In the past, he has worked as an IT officer for 2 years with the mining business of Aditya Birla Group. So let's invite Saurabh sir for the session.
Thank you, Professor Rutal and Professor Viral, for such an amazing introduction. And as the introduction is already clear with each and everyone, so hello and good morning to all of you. I am Saurabh, again speaking with you for probably next 1.5 hours. So the topic that we are going to learn today or discuss today is enabling collaborative processing with the Internet of Things for Industry 4.0. Now, a question comes in mind when reading this particular topic that why to go through this particular topic and why I should learn all these very designated with design given titles like collaborative processing, Internet of Things, Industry 4.0. Okay, so there are three reasons why I have chosen this topic, and at the same time, I also would like you to go through this particular session and understand. So those three reasons are: first, you see, the technocrats must know the background of industrial revolution. Now, the question may arise from your end that why I should know the history of industrial revolution. I know that industrial revolution took place of like 200 years back, and we are currently in the fourth phase of industrial revolution. But the thing is, sometimes it happens that we do not know basically that what are the 5W and 1H. Now, your question could be that what is 5W and 1H? So, see, before going to these concepts, I would like to say why technocrats should know this particular topic, the history of this topic. So, we should know that from where we were 200 years back and where we are now. And then whenever there is a tendency among us that whenever we get a topic, a project, we start basically the finding the solution of that particular problem, okay, without knowing, okay, why, where, which, okay, then when, and for whom that particular solution will be applicable, and that particular problem is also intended to be solved, okay. And one H that I talked about is how. The second point or reason that I gave for choosing this topic is that IoT is still received as a debatable subject. The reason being is the standardization is still in the process. However, the European Union is going towards with wonderful work as of now, and in a few years we will see that the standardization will be in the place. But because of certain level of heterogeneity involved and other characteristics that we will see in this particular discussion, the problem of IoT being taken as a debatable subject. So I will go through uh, the basics of IoT and let you understand what are the technologies and what are the things, what are the research topics that are involved in IoT. And the third reason is, you see, whenever we are going outside, we are discussing among us, we are seeing the media, we are seeing different kinds of news. We say that the smartness is everywhere. We talk about smart village, we talk about smart city, we talk about smart people. Okay, so however, everything is smart. We want it to be smart, but what is the reliability? Okay, so I have a road from so like I'm living in Jaipur. From Jaipur to Kota, I have a road. But if that particular road is blocked, how will I reach Kota? So there must be some other road, correct? So that's where the reliability comes into picture. If you are talking about smartnets, it's fine, but what are those techniques and technologies that we will utilize so that those smartnets can become that much reliable that when those smart objects are with us, we can be able to rely on it for our daily day-to-day activities. So in this particular aspect, we will talk about the collaborative data processing. The So let's start our discussion for today. You see, I will start with the case study. So the title of this case study is Sustainable Development for Business Operations in India. Now, this was the project that I was working on when I was working with mining business of Aditya Birla Group. So, with this case study, I will let you understand a few points, a very basic problem that we are facing, especially in India, and then we will have a go through in this session to understand how to solve or how to apply our mind so as to come up with the solutions. Okay, so sustainable development for business operations in India. So what happens in sustainable development? You see, the different businesses are operating all across India. Okay, like if we take the example of Aditya Birla Group, it has clothing line, retailing, it has mining business, it has cement business, okay, and etc. etc. Aluminium business, Hindalco you might have heard of. Okay, so but the thing is that when a business operates at a particular location, for example, if we see the operation of mines, so we are basically digging the holes in the soil, and at the same time that particular field that was green field, we are basically making a hole in it. Okay, so what government says that whenever you do certain business operations, after that it is the responsibility of that particular company or that particular business to uh, to have a sustainable growth of the surrounding. So what happens in sustainable development? So how the living index of that particular area is, the business is responsible to improve that living index. Okay, second question arises, what is the water quality, what is the air quality? Third question. Fourth point could be, what is the education status? Okay, so you might be saying, and you might be thinking that why the business is involved in all such things. But this is the fact that when a particular business operates at a particular location, it is the responsibility of that business to see the growth of the people surrounding it. Okay, so that comes under the concept of CSR. We'll see. So CSR basically expands to corporate social responsibility. Please keep it in mind, CSR expands to corporate social responsibility. So this is a division in every firm and business, whether it is Reliance, is it Aditya Birla, it is Tata Group, whatever business it is, CSR is part of that. As per government norms, whatever the profit comes yearly profit is received by the firm or by that particular business, 2% of that profit should be invested in the sustainable development of the surrounding of or the society in which that business is operating. Okay. Now, why I have taken this particular case study? With this case study, see, sustainable growth, everybody is talking about, and we can have an index that is given by the government. That index is also fixed by the different businesses. On the basis of that, they show the sustainable growth. But being technical guys, we should understand that the remote sorry, not this being technical guys, we should understand that to have sustainable development, we have certain problems and we have to find the solution to it, where we as computer engineers, computer science developers, or interdisciplinary teams with mechanical engineering, computer engineering, electronics engineering department guys have to come up with the solution in terms of projects or in terms of research. The first important topic that I want to talk about over here is the remote location. You see, whenever we say the concept of remote location, the first thing comes into our mind is the location where everything or the basic necessities are not available to us. Okay, the basic necessities could be, in the current scenario, those necessities could be like the mobile communication, the internet, okay, and the proper roads, okay, transportation, roads in the means in such a way that transportation is not proper over there, okay. But this was the situation in India. I'm talking about for a remote location. The situation we are discussing as of now, these situations are these basic necessities are basically there. Nowadays, people in remote location can also have minimum 3G network available to them. Roads are either perfectly built, or they are in operation in such a way that they are having such kind of roads where they can commute to the nearby districts and good cities, okay. And at the same time, the basic necessities like house and everything is there, okay. Now, the why I want to discuss this particular location, you see, in my experience, I'm telling you what is the problem with remote location. Now everything is accessible to you. So we were having a problem of giving internet connection to a location that was 50 kilometers from our office location. At that time, what we did was we took one OFC cable. Okay, that OFC cable is our fiber cable, TV cable, you see. So we installed fitted the transceivers at both the ends, and then we transmitted the internet connection to that particular remote location. The problem with remote location is that the basic education or the basic moral behavior, that is also one of the aspects that we have seen at remote location. What happens, people cut that particular wire and they start utilizing it for soaking their to dry up their clothes in their houses. So in that case also, it becomes a problem for us technical guys like us, who are giving the solutions, but those solutions are not getting effectively utilized. So the downtime is more for internet, and the internet is not that much accessible to that particular area, okay. So this is one of the problems that we have faced in the remote location. We have already discussed about the CSR activities of businesses around the world. What happens in CSR activities? 2% of the yearly benefit will be given for the sustainable development of the surrounding, means their education, their basic provide basic necessities. Like during winter, the business provides them the this daily important things that are not that much accessible to them, okay. So this is the responsibilities of the business, okay, and it comes under CSR, that is called corporate social responsibilities, and this CSR is also a part of MBA program. Third is meaning of sustainability. When I say sustainability, what is its meaning? So the people in that particular surrounding can be able to sustain their life in such a way that they are working with the particular business, means in such a way that the business operates there and gives them job, but at the same time they also do their jobs in that particular business in such a way that the people have good education, they get good facilities over there, good like drinking water facility, like best air quality facility, okay, and all the things that are taken care of by the uh, business people. Then sustainable development efforts, I have already discussed two examples like water quality and air index. Other could be the education and other reforms. They also, the business also takes care of their field works, like whether they are getting good amount of seeds and better quality seeds for agriculture. They have better fertilizers for their agricultural land. Okay, so all these comes under the development efforts, and there are certain parameters and conditions which affect the sustainable development, like one could be the socio-economic condition, and second is the technique effectiveness of the technical or technological progress that we have made, and the amount of efforts we put for best suitable implementation of that particular technology in that location where that business operates. However, there is a requirement of necessary improvements, and we will see what are those improvements. And technocrats are basically working on implementing such kind of solutions, and for to improve the conditions of them. And as already discussed, the impact of socio-political environment is very important. We have to take care of this at while implementing our solution. We cannot say that we are engineers and we are technical guys. We are given some laying of OFC cable for 50 kilometers. We are given that particular job. I will do this job and I will go through with it and get my salary, or get my whatever the it was given money that was given in purchase order. We have to think about the people who are living there. We have to talk with them, and while laying and digging the hole for laying that particular OFC cable, we have to make them understand that what is going on and how it will be implemented, and how their lives will be affected by it. And finally, the technological benefits. There are different technological benefits. We can see that we talk about AI, but at remote location, this AI is not that much. But yes, you see that at remote location also, the television is readily accessible. There is no place in India as of now where television is not accessible. If it is not accessible at that place, because maybe that is the reason of environmental factors. Okay. Now we will go towards our main topic, that is called the technological revolution. You see, the technological revolution can be categorized into pre-industrialization and industrialization area. When I say pre-industrialization area, means era. So I'm sorry, I said area, it's era. So pre-industrialization era means when we will talk about the agricultural era, means the main focus and main work of the people was basically doing they were involved in the agriculture in the fields. Okay, and then the industrialization era came, and we will discuss what are these particular topics, and what are the different characteristics, and what happened in these era. Okay, so to define technological revolution, it is a period in which one or more technologies is replaced by another technology in a short amount of time. This is the definition of it. And what happens? So it is an era of accelerated technological progress, and it is characterized by new innovations. Some new innovations you have done, and because of that, some technological progress has accelerated. So that is basically defined, and then it is combined to form a concept of technological revolution. Okay, now there are two important aspects that we must understand whenever we discuss technological revolution, that is the productivity and efficiency. Whatever we are doing for technological process or accelerated technological process and new innovations that we are discussing about, so that is because we want to increase our productivity and increase our efficiency. In a more technical way, we should say optimize the productivity and optimize the efficiency. Okay, so optimization means, so as per the need, we want the productivity. It cannot be like I have I have invested 50 rupees and I cannot think of coming up with very unrealistic kind of expectation. So the productivity and efficiency should be optimized. So that's what the technical revolution also focuses on. So what are the potential impacts of technological revolution? So those are like material or ideological changes, changes in the business management, or improvement in the business management, improvement in education, social interaction, finance, research methodologies. I can give you one example. Like the education has really in last 14 years, it has 14 or 15 years since 2005, it has improved a lot. At that time the laptop was not so accessible, it was very costly, and we see that laptop is everywhere nowadays. Each and every person, they have at least one laptop at their homes, even if they are not having those laptops or computer systems or desktops with them, and they are not having, they are having basically a smart mobile with them, so that they can understand how the such kind of how Android application works, how Microsoft Windows works. Okay, so that's what the technological progress is. Okay. And there are two characteristics which outlines the technological revolution. The first characteristic is the strong interconnectedness and interdependence of the participating systems, okay, in their technologies and markets. And the second is the capacity to transform profoundly the rest of the economy. Okay, so when you are doing the technological revolution, all the participating systems, okay, they must be interconnected and interdependent among each other, and that should be strong in nature. And whenever you are talking about technological revolution, some new technology is coming into the place, so therein we are trying to have some impact or positive impact on the economy and the society where that particular technology is implemented. So for example, if I say self-driving car, it has a very profound impact on the economy also, and at the same time society also. Okay, how economy? Because maybe possible at the initial stages, the automobile, current generation of automobiles which people are utilizing, the production may get hampered, but at the same time the accidents may be less. And final comments from my side, it is at the current stage very much impossible to come up with self-driving car in the situation or in the surrounding or in the environment or the kinds of roads we are moving our vehicles upon. But these characteristics define the technological revolution. You see, whenever we talk about technological revolution, there is a concept called creative destruction. What happens basically, see, the technologies are getting invented, some new techniques are getting invented, correct? So maybe possible they are positive in nature, but maybe possible they have some negative impact. For instance, the coal, when it was implemented, yes, it has some for steam engines, for our thermal power plants, they are very much useful. But you see, it has basically a negative impact on the environment also. So this contradictory nature, where the new invention is also coming, but at the same time it has a negative impact on the environment, it is also known as the concept by the term creative destruction. So the technological revolution can be of three types. One is the relation revolution, wherein you are trying to improve the relation among the people who are living in the society. For instance, with the use of by the new technologies that phones came up, correct? Sectoral revolution, wherein a particular sector is getting benefited by that particular revolution. For instance, green revolution and commercial revolution that took place, wherein the green revolution, what happened, we tried to work upon planting more trees and all. Okay, and then third kind of revolution is the universal revolution. So one example is the second industrial revolution that we will talk in coming slides, and Renaissance technological revolutions, where the sector, it is where the different sectors are simultaneously focused to get the positive benefit of the technologies that have come up. Now, three parameters are there for each revolution to take place, like from first to second, second to third, and third to fourth. We see these three parameters. We see the technologies that have come up. with respect to these three parameters. What are these three parameters? Like, if whether the new technology that has come up, it has new cheap inputs, new products, it is supplying some new products as compared to the previously what we are having, and the new processes are involved in that particular technology. Okay. Now, what happened in pre-industrialization area? Let me go through it in very brief. So there are upper Paleolithic revolution, wherein there was an emergence of high culture and new technologies. Neolithic revolution, where basically it was based on human civilization to develop. Renaissance technological revolutions, where innovations were during the Renaissance period. So you may ask, you may have this doubt that what is Renaissance. So in during the Renaissance period, a lot of efforts were given to the art and culture to come up. Okay. Then we have commercial revolution. So therein the European economic expansion and colonialism came into the picture. Then we have price revolution, where high rate of inflation was there. Then scientific revolution, where the different scientific experiments came up and their positive or negative impacts were analyzed. Then British agricultural revolution. Okay, so all these things came, and all, since we are discussing all these things, but with each and every thing, those three important parameters will always be discussed, like new cheap inputs, new products, and new processes. So when we talk about the industrialization period, first, second, third, and fourth industrialization has already happened, industrial revolution. We will see all these things in detail in a few moments. Now, briefly, if technological revolution can be summarized, first was the financial agricultural revolution. I don't know how many of you know about Robin Hood, but the stories of Robin Hood, that was in the era when the king Robert of the Lionheart, he was known as the King Robert, and also he was known as Lionheart. So what was the story of Robin Hood? That story revolved along the around the era when the British agricultural period was there, where the more focus was on agriculture by all the family members and all the families of that particular society. Okay, so that era is known as financial agricultural revolution, and the period is also given over here. The main problem with that particular revolution, I'm sorry, with that particular era was the feudalism. Feudalism को हिंदी में हम सामंतवाद कहते हैं. So feudalism basically क्या होता है? A lot of sheriffs were handling their respective areas, and a lot of taxes came into the picture, and agricultural people, even if they were involved in practice of agriculture because of environmental things and all, they were not getting the that much output what they are sowing, and above all they have to pay taxes. So that feudalism, and just this theory, this story of Robin Hood, where Robin Hood fights those that system of feudalism only. सामंतवाद के खिलाफ लड़ाई थी वो, ठीक है. So because of that, people started having lesser faith on agriculture, and the concept of industrial revolution came. This industrial revolution in the second point is also known as the first industrial revolution. Then the technical revolution or second industrial revolution came. Then scientific technical revolution came. Then information and telecommunication revolution came. That is also known as third industrial revolution or digital revolution, where the focus was on information exchange, communication. Okay, and then fourth industrial revolution, that is still going on. It was coined in 2014, this term, fourth industrial revolution, and then 2019 onwards, it has taken a grip in the market, and now it is in the place, and people have started working on it. Now, there are two concepts, technical and technological revolution. So people get sometimes very much confused in it. So that's why I want to clarify this particular topic. So what happens in technological revolution? It requires material changes in used tools, machines, energy sources, or production processes. However, in case of technical revolution, it is restricted to changes in management, organization, or non-material technologies. So what could be the example? Like the progress in mathematics and accounting is basically technical revolution, and with the use of this, if you are coming up with some technology, okay, so it becomes a technological revolution. Now let's talk about first industrial revolution. Normally it is not written as industry 1.0, but I have written it just for the sake that you understand that we are talking about this first industrial revolution. It becomes very easy to understand. That's why I wrote industry 1.0. So what happened? This is the basically history about it. What happened was it was the transition of new manufacturing processes in Europe and United States. So it started basically in Great Britain, and many technological innovations came. What were those innovations like? What was the transition basically? So hand production methods were utilized, so it was converted to machines. New chemical manufacturing and iron production processes came. So people used to previously break iron with hands. The machines came into the picture, and then the concept of mining came in first industrial revolution. Then the increasing use of steam power and water power came, and the innovation and of coal also had a very positive impact on the increased use of steam power and water power. Then the development of different machine tools were seen. The rise of mechanized factory systems were seen. Prior to that, I told you that prior to first industrial revolution, people were more focused on the agricultural fields, and they were doing a lot of means they were fully involved in agriculture. But slowly with the innovation of coal, then steam engine, then water power and machines and all machinery tools and all, the factory systems also came. So people started working in factories rather than working in the fields. So and one very important thing that was seen by the historians, that during first industrial revolution there was an increased rise in the rate of population growth, because they get more satisfied. They tried to improve, increase their family. They were more satisfied. They could be able to give certain environment there where they can increase their family. So that's what the reason historians say that the rate of population growth increased during the first industrial revolution. Now, what were the fields of technological development? Like textile manufacturing started, iron industry, steam power, machine tools, the chemicals came, paper machines came. Okay, and mining and transportation also started. As part of transportation, they started building the good roads. Okay, concrete roads and all. Okay, good roads basically. I am not saying the concrete road, because later on everything came in, means day by day, the more advanced versions of or more better roads are getting built. Okay. Society was also getting affected because of that. Why? Because people stopped working on their fields, and they started working in factories. Okay, so standard of living like food and nutrition, housing, sanitation, water supply was improved. Then literacy was gradually improved. Then clothing and consumer goods, because of textile industry. Okay, then population, as discussed, it increased. Urbanization came into picture. Then very important point, effect on women and family life. You see today that men are working outside. Women are still in India. We see that a lot of women, they are working at homes, being a homemaker. Correct. So previously it was housewife, then a new term called homemaker comes, and it's a very positive term for those women. But to tell you the truth, before first industrial revolution, even the women of the family used to work in the agricultural fields. And after first industrial revolution, it came into the picture. This factory system came, and men started working outside and women started working inside. So when I'm saying that women started working inside the house, means they were weaving the clothes, they were working on the textile based things, like वो जो आप देखते हैं गांधी जी सूत काटते हैं. Correct. So that particular such kind of machines started building, and women started working on those machines to come up with so as to benefit the textile industry. Then labor organization and start of child labor also started from that particular area. Okay, and environmental also got affected due to gradual rise in smoke and pollution, and I have been discussing that coal was a major factor for that. Then comes the second industrial revolution, that is also known as technological revolution, and it was a phase of rapid standardization and industrialization. from the late 19th to the 20th century. Not going into so much history, what were these are the industries and technologies that were developed or that were improved from first industrial revolution in some or another way, like iron, steel, rail, electrification came, petroleum, okay, like paper making, okay, paper making was advanced basically. So chemical industry, machine tools, okay, modern business management came, telecommunication came, engines and turbines came. Okay, so all these industries and technologies came as part of your second industrial revolution. Then comes the third industrial revolution, that is also known as digital revolution. So it is considered as the shift from mechanical and analog electronic technology to digital electronics. Okay, now as part of digital electronics, MOSFETs, digital logic, IC chips, all microprocessors, cellular phones, internets, all these innovations were done, and they were very much fruitful for the society. So they have transformed basically the traditional production and business techniques, okay, because of using these technologies that we have already discussed in the third point. There were socio-economic factors like the concern of information sharing and privacy came with third industrial revolution, that is your digital revolution. Then copywriting and trademark issues. Then the concerns for storage and verification of data. You see, whenever you talk about Ramayana, Mahabharata, your Vedas, because they were handwritten, it is still available in some or another form. If we will not talk about this, then the Renaissance period of art is also available. But if you see the photos that are with you, if hard disk crashes, it becomes very difficult to restore such kind of our data that is that we had before that hard disk crashed. So this is when very big concern for our digital period, okay, where storage and verification of data is a concern for us. Okay, then comes the industrial 4.0. This is basically the topic that we want to discuss for today. So in industry 4.0, basically it is known as fourth industrial revolution, but I would like to clarify over here, it is the subset, very important term, it is a subset of fourth industrial revolution. It is not of the fourth industrial revolution, but it is the subset. So what it encompasses, you see, whenever the industrial revolution was there, they only discussed about industry, but the fourth industrial revolution also discussed, in with addition to industry, it discussed about the smart cities. Okay, the smartness comes, so there in the industry 4.0 came into the picture. Okay, so they are used interchangeably, but industry 4.0 is the subset of fourth industrial revolution. Okay, so the wireless connectivity and sensor systems, the visualization of data, making decisions on its own kind of thing. Okay, all these things comes in as part of your industry 4.0. And industry 4.0 basically is the trend towards automation and data exchanging manufacturing technologies. In fact, if you see, it includes these terms called cyber physical systems, internet of things, industrial internet of things. We will see what is this industrial internet of things, cloud computing, cognitive computing, and finally artificial intelligence. Okay, so whatever is going on in fourth industrial revolution, whatever technologies and terms are there, they can be segregated aggregated in these 5 terms. So to understand how it came, so German manufacturing company, smart manufacturing company, that they came up with this idea in 2011 to promote the computerization or of manufacturing process. So this industry, you see, it is IE 4.0, was publicly introduced in the same year by at the Hanover Fair. Okay, Hanover Fair happens every year, okay, in Hanover, and therein this concept was coined. Okay, and then a lot of things happened, like the working group was formed, and as part of working group, final report was also submitted. Okay, and this working group was headed by scientists like Siegfried Dies, who was working with Robert Bosch, and Henning Kagermann, who was working with German Academy of Science and Engineering. So this is how the origin of Industry 4.0 can be visualized. What are the strategies? You see, everything now in Industry 4.0 is self optimization, self configuration, self diagnosis, okay, taking self decisions, intelligence came into picture, okay. However, the design principles and goals are also there, like we want interconnection between everything, we want information transparency, okay, like RTI, जो भी information है मुझे मिलना चाहिए भाई, मुझे पता होना चाहिए कि what is going on, correct? So information transparency is there. Technical assistance, decentralized decisions. Previously it was centralized, raja hota tha, and that raja was responsible to get every information from all the this people uh, who were scattered all around the country, and then the decision was of that particular king to decide on what to tell the public and what not to tell. However, the decentralized decisions came, means each and every person, they are educated, they can form the can form the decision solution strategies, and then they can think upon it, okay. And at the same time, this decentralized decisions, whatever the topics I'm talking about, like interconnection, information transparency, technical assistance, and decentralized decisions, they can be thought of as part of artificial intelligence also. Like if you work upon it, your intelligence of machine increases, okay. And these are the components of industry 4.0, like mobile devices, IoT platforms, location detection technologies, 3D printing, smart sensors, big data analytics, all big topics, fog, edge, cloud computing, okay. So what basically we want to achieve in industry 4.0? Real time task execution.
બંધ થઈ ગયો. હા હા હા, મને નહીં દેખાતું એટલે મને
Uh, am I audible now?
Yes, sir.
Yes, sir. Yes, sir.
Shall I continue?
Yes, yes.
TPD.
Sir, open your presentation. Sir.
Is it okay?
Yes.
Okay. Okay. So because of certain disconnections, this happened. Since you see, we are not in remote location, but at the same time, this happened because of the same issue. Like the internet is there with us, webinar can go on, but what happens if the connection is not reliable? Okay. So we were when we stopped at this at that time we were discussing about industry 4.0. So to let you understand, this industry 4.0 is the subset of fourth industrial revolution. And when we discuss about fourth industrial revolution, it is normally classified as industry. However, in fourth industrial revolution, a new concept also came, that is called smart city. And this in industry 4.0, the important topics are cyber physical systems, IoT, industrial IoT, cloud computing, cognitive computing, and artificial intelligence. Okay. Now, this is the origin. Let me go through it once again. So, uh, so it started in 2011. This particular term was coined by German manufacturing company, which was promoting the computerization of manufacturing process. And Industry 4.0 was publicly introduced at Hanover Fair. It happens every year. Then in 2012, the working group of Industry 4.0 was formed, headed by two scientists, Siegfried Dias from Robert Bosch and Henning Kagerman from German Academy of Science and Engineering. And in Industry 4.0 was presented in 2014, 13, then 14 it was more standardization took place, and from 19 onwards people have started working on realization of Industry 4.0. These are the strategies where everything is focused on self optimization, self configuration, everything is self. Okay. So self diagnosis, you have, so we are giving basically intelligence to the machines. Okay. We are making them intelligent so that they can perform tasks autonomously.
Actually, hello.
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 Yes, sir. Yes, sir.
Okay. Okay. So we were when we got disconnected at that time we were discussing about the strategies, design principles, and goals. So so these are the components of Industry 4.0, and it can be summarized into four components: cyber physical systems, IoT, cloud computing, and cognitive computing. Okay, so there are three basically drivers for Industry 4.0, like digitization and integration of vertical and horizontal value chains, digitization of products and service offerings, and digital business models and customer access, where we are more focused towards the customer satisfaction. There is a fun fact. We listen about industrial internet of things a lot, but if you want to know about it, so the use of industrial internet of things is referred to as Industry 4.0 at Bosch company, and generally in Germany basically. Second fact, that the applications of industrial internet of things are more focused towards predicting the failures and triggering the maintenance processes autonomously or in self-organized way. There are different challenges, like economic challenges of Industry 4.0, then social challenges. Okay, how if you implement the technologies, then how it will impact the society. Then political challenges are there with respect to regulations and policies that needs to be prepared for this Industry 4.0. And finally, the organizational challenges, wherein we talk about the security issues, reliability and stability, machine to machine communication, integrity of production and processes. Then if there is a need to protect industrial know-how, so when I say know-how, means it contains in the control files for industrial automation. Okay, then lack of adequate skill sets, this is the major problem. Because of that, insufficient qualification of employees we are facing, who can work with such kind of technologies, and we need to have some educational policies and training policies for them so that their skills can be improved. Low top management commitment. Okay, you see, our Modi government has come up with a program of skill development that is very unique in our country, and it focuses on giving such kind of training, innovative training to the people who wants to get involved and get trained with. Okay, and this is a very good this initiative that is taken by government. It is very much required, because all around the world the countries are doing such kind of thing to work upon the technological progresses and be with it. Now, the next topic that we are going forward with is ICT and IoT. Okay, so when I discuss ICT basically expands to information and communication technology. So what basically happens in information and communication technology, the smart world, for that we want the communication and communication technology to be built in such a way that the information exchange becomes very easy for us or for the society. Okay, so what it includes, the device to device communication, and it stresses on the role of unified communication. Means the communication technology should be adopted in such a way that it cannot be said that if I use phone, I cannot use a laptop for the same thing, and if I use some application on laptop, it cannot be utilized on phone. You see, the smartphones nowadays, they have the apps that can be portable from laptop to phones or vice versa. Correct. And it enables users to access, store, transmit, and evaluate the information that is basically getting transmitted using the communication technologies. The skill frameworks are there, like categories, wherein we define the strategy and architecture, skills and quality, relationship and engagement, then responsibility, and then generic description. You see, all these 3 points, if you implement in artificial intelligence, you can come up with a very concrete kind of intelligence in the machines. This is the ICT breakdown development, ICT technology development breakdown, wherein we see that the most of the cost is involved in personal development, then we go towards the software cost, that is 29% of total expenditure, and then the hardware cost, and finally the external service providers, they are 14%. In the means this is basically the in the development they have 14% of the roles. Okay, personal cost is more. A few stats, like 4.5 billion people have access to the internet, and we out of every 10, 8 internet users are using internet on smartphones. Information and data access in real time is ever demanding in current scenario. Okay, now what are the critical issues? Again, developed versus developing countries, because of the kind of GDPs and the kind of uh, uh, expenditure and the kind of the efforts the developed country can have, because of they have more uh, machinery and tools, and at the same time better skills of the person to come up and work on such kind of technologies. Okay, that developing countries, they are still working upon it. Or how to penetrate remote areas, I gave you one example how remote location works. And then cellular coverage is there or not, electronic transmission, what is the backbone network. Okay, so based on that also, these issues need to be solved to come up with better information and communication technology. Now, when we discuss about IoT, it is basically the scope of connecting and communicating among devices around the world. Each and every device in the world are in connection with each other. So it uses the internet for why? Because use of internet is crucial. Why? Because the devices are energy constant. It has limited computing power devices, so it cannot transmit to longer distances with its own technology. So let's use internet to transmit devices, the information from those devices all around the world. Okay, and distributed devices are there in IoT. They are of different types, like they can be sensors, actuators, servers, mobile stations, many more such kind of devices could be there in IoT. There are certain issues related to IoT, like network architecture, system design, how you are covering a region, how you are connecting the physical IT and different business infrastructures, intelligence and quality of services associated with IoT, mobility and routing and on-the-move configurations, how you are supporting the massive amount of devices, their robustness and self-organization if required, and how you are integrating the different technologies. You see that different mobiles work on different platforms, and different OSs, different laptops are there, different devices have their own configurations. So how you can be able to integrate those technologies, protocols and platforms, that is basically the issue concerned with IoT. These are the parameters that affect the performance in IoT, like how you deploy how the devices in the terrain, how you connect those devices, how to improve the response time, how to consume the energy of those devices, how to improve the lifetime of those devices and the network, and how to improve the reliability of the network as a whole. Okay, so when I talk about the Internet of Things, basically the purpose of it is to create a global network interconnecting smart objects by means of extended internet technologies. Okay, why? So it supports a range of technologies, and the goal is to develop applications and services using such technologies in global business world. Now there are three conceptual pillars of IoT, very important. All the devices must be identifiable. First conceptual pillar of IoT, they must have unique identification of themselves. Second is they must have communication capability, and third is they must collaborate among each other to process certain tasks. Okay, these are the three conceptual pillars of IoT. First, they must be identifiable, they must have unique identification, either in terms of IPv4 or IPv6 address, or certain IDs, identification IDs. And second, they must communicate. And third, they must communicate among themselves, collaborate among themselves to execute certain tasks. Very important point of IoT. That is the conceptual pillar. Then comes how an IoT device is created. You see, you take any device, okay, you add computational intelligence to it, and you get what you will get. You get that device with computational intensive. Means that device will be computational intensive because you have added the computational intelligence. And now the task is to add network connection to it. Then it becomes an IoT device. I have an example of it. It will be very much clear to it. You see, cellular phone, sensors. In current scenario, the kind of smartphones you use, it has sensors, GPS, high mobile broadband, touch screen, wireless fidelity, high-end display, camera. So the object is a cellular phone. Intelligence you have added like sensors, GPS, camera, wireless fidelity and all, and network connection by the use of high mobile bandwidth. As soon as you added the network connection to it, it becomes an IoT device. These are the IoT building blocks. The first, you must think about the deployment, okay, so as to get broadband infrastructure that is easily accessible to all the users all around the world. Then the use of smart agents, why it is required, because it increases the collective embedded intelligence, okay. Then third, smart spaces, why, because whatever infrastructure you are coming up with, they must be integrated and cohesive so that the portability can be achieved. And then different web applications and e-services must also be supported by IoT and system architecture. Very important, because the data and information will be processed by different devices which are having different kind of communication and computation capabilities. At the same time, they have different processors and processing capabilities. So all these things must be kept in mind in developing a very concrete kind of IoT infrastructure. These are the challenges you see whenever you want to go for building such you want to build IoT infrastructure with the use of building blocks. You may get conditions like hostile environment, you have remote location kind of scenario, mobility is there, the devices, the mobiles are in the pocket and the users are moving here and there, how they can be connected, the coverage, okay. Then the terrain limitations are there. The terrain may be regular, they may be irregular, the mountain is there, the river is there, the line of sight is there, the non-line of sight is there, okay. The trees are coming in picture, okay. So how you can overcome such kind of scenario. Then how to improve the communication performance, the heterogeneous characteristics. I told you already that different devices have different configurations, how those devices can be made portable. Energy harvesting, processing architecture is there, okay. And finally, the localization, okay. This is very important because all the services and applications can be efficiently accessed if the location of those devices are known, okay. Now, very important topic that we are going forward with, that is collaborative data processing. So we should know 4 important terms before going forward with understanding the collaborative data processing. First term is the communication, okay. What is basically the communication? So it is the exchange of ideas and information, very basic. Second, cooperation. What happens with cooperation? So in cooperation, a group is working. If I am working and I need some resources and information from your end, so it has to be achieved using conscious and deliberation efforts, okay. So it is, this particular concept is called cooperation. Then coordination. So what happens in coordination? The actions of users are directed by a coordinator to achieve a common goal, basically. And then comes the concept of collaboration, where all the people involved in a particular project are responsible to achieve a desired goal, and they all are willing to work collectively and with same effort to come up with the solutions. So in that case, that particular concept is known as collaboration. This is very important. And finally, what is a task? So if you, because with communication, cooperation, coordination and collaboration, you want to execute certain tasks. So what is a task? It is a schedulable function or feature executed in temporal scope. With time, different tasks are executed. That is what is referred by saying temporal as scope. And these tasks may be periodic, aperiodic, they may be spontaneous, sporadic, deadline based, and they may be precedence based, okay. So the tasks can be defined like that. To define collaborative data processing, basically it is the collection and management of data from one or more sources and how you distribute this information to the destination. That destination could be one or many. Goal, why collaborative data processing needs to be done? To control, process, evaluate and report data and information activities, okay. And there is a need of collaborative architecture and algorithm to achieve the goal that just now we discussed. There are key issues. The key issues with collaboration is how to perform effective collaborative signal and information processing. For that, first point is how to dynamically determine what needs to be sensed, who should sense, how often the information must be communicated, and to whom it must be communicated, who should compute, and how this computation needs to be done. Okay, all these things comes under the umbrella of this collaborative processing. Okay, so from viewpoint of collaboration, the services offered are cooperation, competition, and self-organization. But at the same time, the categories of WSN enabled, see, IoT में WSN तो आएगा. Okay, so wireless sensor network is an integral part of IoT. So therein, it can be categorized into collaboration based WSN. यहाँ पे क्या होगा, basically you have certain collaborative algorithm with you and you are trying to create a WSN, wireless sensor network. And second category is WSN based collaboration, wherein you have a sensor network and you want to do certain operation by innovating or by coming up with some collaboration theory. Okay, this is the major difference. Now, technical issues in CDP, I always give a very basic example to understand the collaboration. You see, the star here gives the event that is happening. So this event, because it is the communication range of these two devices, this event is sensed by both the devices. So both the devices will send the data, as you can see in this B, diagram number B. Okay, so both the devices are sending it to the final root node. However, it is not desired because the final root node will get the same data twice. So how these two devices will collaborate, what algorithm will be utilized over here so that only one of them will send the data. Okay, at the same time, that data should be accurately and in a timely sent to the root node. This is one of the basic things that we should understand when discussing the collaborative data processing. There are different characteristics like power consumption, ability to cope with node failure, mobility. Okay, we have already discussed how the data processing needs to be done, power consumption, okay, ability to withstand harsh environmental conditions. At the same time, you see the different key evaluation metrics are there that will be more clear with this particular diagram, wherein the collaborative data processing can be network based and QoS based. Whenever we go for network based, therein we talk about deployment, coverage, localization, where we find the location of the devices, and clustering, where we cluster those devices based on their location. And QoS based, that is the quality of service based, wherein energy conservation is there, lifetime, connectivity, reliability, okay, and response time. These topics are discussed. Now here it gives the layered architecture of collaborative signal processing. What happens over here? This line you see below it, all the things are hardware based, where you are receiving the signal, you are sampling, filtering, and finding the threshold, you are processing the signal, you are fusing the signals, and then you go for further collaborating with your neighbors, fusing with the neighbors. Fusing means you are sharing it with the neighbors, and then beam formation. So what happens basically, as you grow from down to up, your quality of signal increases, your false alarm rate decreases, okay, then the detection increases, detection rate of signals, and the power consumption also increases, because you are doing more amount of operation as you go from lower layers to upper layers. Here it says the three research areas, okay, data and information sensing is one of the area, communication of sensed information, and third, very important, that is your computing. Okay, so that they come under the collaborative wireless sensor network, wherein the event occurrence is there that will be sensed by collaborative sensing, then it will be communicated, then computation needs to be done, then certain information is extracted, and then it will be routed further for the purpose of sending it to the node where the all decision making takes place. When we talk about collaborative sensing, what happens basically, some anomaly is detected, it is sampled and filtered as discussed in the layered architecture before, threshold is compared, information is fused, then signal quality is improved. This is basically the collaborative sensing. And then the attributes are there, like size of sensor, on the basis of that sensing extent, operating environment, energy availability. On the basis of that, basically the collaborative sensing operation is done. When we talk about collaborative communication, it depends on type of communication, what kind of device composition is there, dynamics is there, what is the speed, memory, bandwidth, nature of communication, data access. Okay, all these things defines the collaborative communication. And finally, there are three important collaborative computing models. One is centralized, then distributed, and hybrid computing model. When we talk about centralized computing model, it is client server based, where centralized, the server contains all the know-how parameters and the clients request the execution of services. And in this case, migration unit is data. What is migration unit? So all the client and service, they want some data to be processed at the server and responded back to these clients. At the same time, when we talk about distributed computing model, herein the server, so if there, the server basically knows only the know-how service, and all the resources are there with the client customer. So this is the distributed computing model. And hybrid computing model is basically where
Dear participants, please stay connected. Due to connectivity issues, this inconvenience is occurred. Sorry for that inconvenience. Speaker is coming soon to answer your comments.
Hello. Hello.
Hello.
Am I audible now?
Yes, yes, sir.
Okay. Okay. So, first of all, I am so sorry because this was an unexpected situation that has occurred where the connectivity is lost because of this electricity is gone, and this is also one of the real-time situation that we have been discussing during our uh, this discussion today.
It's okay.
So, the
It's okay.
last so for all the participants, the last few topics, actually 2 or 3 slides were remaining because before what has happened. So the last few slides were discussing my own comments on the situation that we are in, and uh, why after what to do after we have gone through this particular expert talk. Okay, so first of all, my first comment is that go through the industry 4.0 governmental policies and guidelines. It is very well written by our government and is there on its their website. So go through it. This will help you in understanding that what kind of projects government is trying to get from the citizens, and what they want to try and implement for their citizens. So if you work upon it, you will be able to working for industry 4.0, and by adhering to the guidelines what is given by the government. Second is whatever we have discussed in collaborative data processing. The most important part is uh, understanding the difference between cooperation, collaboration, coordination, and communication. And finally, what kind of task you want to perform. So basically, you will try to implement certain algorithm in these categories: collaboration, coordination, and cooperation, where either one is coordinating all the activities, then it will come as part of coordination. Cooperation, so I am not saying that collaboration is better than cooperation and coordination, or cooperation is better than the other two, or coordination is better than the other two. But what I am trying to suggest over here is that pertaining, or the kind of real-time situation or the problem you are handling, you think that what could be the effective solution of you can come up with with respect to these 3 or 4 terms. Okay, and final comment is that don't think IoT as being a very big thing. IoT is just an environment where two kinds of devices lie: sensor devices and IoT devices. IoT devices can be well thought of a device which is connected to the internet and has computation and communication capability and high power. Okay, and at the same time, sensor devices, they are the enablers. They sense the things and they pass it to the IoT devices to uh, uh, further being communicated to the other IoT devices, or to the base station where all the decision making takes place. This is basically IoT, where all the devices are IP enabled. Now, a confusion comes like people ask me that, sir, IoT devices. So, Arduino is an IoT device. Yes, Arduino could be an IoT device if it is connected by an internet, okay, or by a network. Okay, so it becomes, so three important things you always understand with respect to IoT device. One, those devices must be identifiable. They must have unique identification. Second, they must uh, communicate among each other, and so communication capability should be there. And third, very important, they must collaborate among each other for the purpose of uh, performing certain task executions. Okay, so that is all from my end. uh, uh, Professor Rutal, are we going to take questions from now? Oh, Professor Rutal,
Madam,
you are mute.
your mic
Ah,
is off.
okay.
Hello.
So I can see that I can see that Mr. Bittu Paul has suggested me to wash hands. Okay, and okay, and same guy has also given asked me a question: how to validate the new inputs, products, or process that come up with new revolution for their value creation ability? Wonderful question. Actually, you see, whenever a new technology comes, now herein I will tell you with respect to IoT. IoT is a new technology, correct? So if IoT has come up, so you have to question or create a question first, and then create a document. So all these things what I am telling you about new inputs, new products, or new process, in fact it is new cheap inputs. Okay, so you have to question that if I use IoT as a solution for a certain application, will it produce a new input? Yes, for IoT it is there, because previously you cannot able to uh, uh, communicate to longer distances. Like if you have a device, it cannot communicate from one one country to another country. So IoT utilizes the concept of internet. So yes, it uses some cheap input where at a very cheap cost you are getting the internet, and the product that is getting delivered is is in the form of the information that is communicated to longer distances. Okay, and yes, of course, the process is very simple over here, and it is also very new, very cheap and new. Why? Because the process doesn't involve very hard and fast. We all are skilled, so we know how to configure internet and how to work upon that uh, to devise the solution for that particular application. So in this way, I say that you think about it and prepare a document about all the list of things in terms of cheap inputs, new products, and new process, and then you go for standardizing that particular technology as part of certain revolution. Okay. Devarshi Nayak has said that, sir, as we know, IoT combines IT and OT, operational technology and information technology. Yes, I am with you in this particular thing, because with the use of internet, you are trying to revolutionize the operational technology itself. So, yes. So, is it feasible to make only OT as dynamic operational technology? Yes, you can, because internet will be there. I think internet will be there. So uh, with the use of internet, you can create dynamic solutions for operational technology. So I am with you. This you can. It is feasible. It is feasible, but we have to think of means very basic thinking we need to do for the purpose of devising solutions for operational technology. Like logistics, you see, IoT is getting implemented in logistics in the manufacturing industries. Okay, so in that case, the operational technology is also getting revolutionized. Okay, so your question is also like we need whole component, that is IoT in industry 4.0. See, here when you ask that do we need whole component that is IoT in industry 4.0, my answer to this is, you see, IoT is sometimes also getting confused with a very big thing where something is there, all the devices are getting communicated. Okay, this is not. It is very simple. You are trying to like let me give you an example. Like one like logistic operation, you are trying to revolutionize the logistic real-time logistic operation by embedding some sensors on the trucks, or embedding some sensors on the belts on which the in the companies from where the products move all around the companies, are also with by the trucks with which that particular product moves to all parts of the country. Okay, now those sensors are sensing either the location of those trucks and then sending it to the base station. In the base station in this case is basically the industry, that has sent that particular load or that those products to the different parts of the country. Okay, so herein what you basically are doing as part of whole component, you are only using the internet part of the IoT, and you are utilizing the sensors to sense the information and send it via internet to the uh, your industries or your base station. Okay, so I think that's all in the questions. So over to you, Professor Viral and Professor Rutal.
Okay, sir.
Sir,
Thank you, sir. Okay,
one
madam.
more comment. Sir. We can make a local server as IoT cloud server.
IoT cloud. First of all, see, uh, again, very good question, but I would like to segregate this question into two parts. You want to create an IoT cloud server, means you are trying to create a cloud, or an IoT means see, this is very confusing. Okay, so when, please understand, when I say IoT means it is an environment that consists of two kinds of devices, sensor devices and IoT devices. Those are the two kinds of devices, and IoT is an environment. When your cloud is connected to the internet, okay, so cloud is an entity that is basically an enabler to IoT. Okay, you sense something, and you uh, after sensing that particular thing, you are sending it via internet to the cloud. So you are utilizing cloud for either visualizing all the data or do certain processing. Okay, so it can be, cloud can be seen as an enabler to IoT, or a helping hand of IoT. Okay, so when I say local IoT cloud, you can create your cloud as as a helping hand to IoT. Okay, that is my answer to it. Arti Parikh has asked that, hello sir, can you throw some light on what could be the topics or points on which our students can work in their BTech project using industrial IoT concepts? Very good question. So Arti, I would like to suggest you to go to, see, what happens since you are student, I have seen that particular phase where we come up, we face our final year project, and we think that let's think about some project, submit it and go away. Okay, so what I suggest you that you uh, before taking the project on IoT, you go through the basics of IoT. What are the problems that you want to solve with IoT? And then again, how IoT will help you in solving that particular problem. And again, the question you that may be coming in your mind when I say that uh, uh, you have to come up with the problem also, you have to come up with the solution also, then you have to think whether IoT is part of that solution. Okay, so herein the government guidelines and your minute observations of your surrounding will help you. Okay, where, because you have to think of that particular problem in such a way that it is trying to address, and if at the same time it is if it will become some, if it will have some effectiveness in society. Okay, we do library management project because it is very much beneficial for library to handle their books with the use of that library management software. Similarly, if you want to do some project in industrial IoT concept, you must think about the different problems in industries, and at the same time different IoT concepts, and what are the different problems and how that problem, why you want that problem particularly to be solved for the benefit of the society. Okay, I think
So I
no
want
more.
to add to that question. Uh, means the last question that you answered. What from where we should start for working on this industrial IoT concepts? Means as a student, they are blank for IoT. Then from where they should start learning for this IoT concepts to work as
Okay.
a project?
Okay, so again, this is a very good question, because when I started my research at that time, I also faced the same issue. So first thing, first point. So I will give you a point-wise description on how to go further. So first, what you do is you go for the working group of IoT forum, and you understand what IoT is from their point of view. Okay, because if you will go to Wikipedia or very means all the random websites that are there on the internet, they have their own concepts of IoT. I think if you want to understand the concept of IoT, you should first go for the working group committee of IoT and European Union that is working on this. Second point, you go and learn about the different guidelines and policies of Industry 4.0 and IoT of our Indian government. That is very important. We never go to it. We never go and read about it, but that is very important because we are in the country where they are also trying to do something in IoT. Okay, so we should know that what is their vision and how we can help their vision. Second thing, so this will help you in if you read those policies, you will understand that those policies are intended to towards certain applications or certain problems that the government is also facing in their country, and they want to remove that particular problem. Okay, so this you will get the to understand how you go further with this. Okay, and third is, if you want to learn what is going on around the world, then you go to very big, all the big companies like Microsoft, TCS, then Apple, Google. Okay, they have their R&D websites. Okay, and their R&D centers. So what you can do is either you email them, or else you go to their websites and understand that what kind of solutions they are proposing for different kind of problems in this particular field. Because take my words, uh, in a very sincere way, that I have seen that these guys are working in all parts of this Industry 4.0, cyber physical system, IoT, then your industrial IoT, then artificial intelligence, then cyber security. And I'm telling you that all these things are interrelated. Okay, where somewhere you are working on communication, somewhere you are working on security of that particular communication that you are trying to establish. Okay, so all these things are integrated. Machine learning is also an enabler. Okay, it can be considered as an enabler. So 3 points are there, and final fourth point that I would like to suggest is that when once you have understood the concept, once you have tried to find out the problems with the use of policies that are set by the government, gone through the R&Ds and understood what is going on, then you apply your minute observation skills also to think whether really IoT is necessary. Because I have seen that people are just for the sake of yes, we have to come up with something new. For the sake of that, they are saying that okay, IoT is there. We will just incorporate this concept and we will try to justify ourselves. But that is not the correct way. You think whether IoT is really necessary. If it is not necessary, you go for instead of saying IoT, you go for very basic cyber physical system where only sensors are required and there is no communication required. Don't go for communication. Okay, think the problem in by dividing that problem in very small parts. Okay, then you will come up with a good solution of a problem. Yes, Professor Rutal.
It was, you have given a very nice idea about how to start any work or research work or any kind of BTech project work in IoT. I think this will helpful for a lot for our students. Thank you so much for that. I hope you will come up with such more topics in future to give knowledge to our students and faculty members. Thank you so much for that.
Thank you, sir. Thank you so much, sir, for spending your valuable time with us for this webinar. Sir, your entire session was very good and it is very informative. And it will be very useful to the students, faculties, and to the researchers also. On behalf of SNPIT RC family, I thanking you, sir, for your entire session. Thank you, Rutal Madam, for arranging such kind of webinar. Thank you all. Thank you.
I would like to end this particular session by saying something from my end. So, first of all, I am thankful to SNPIT and RC Umrak Institute for actually conducting such kind of webinars, because this is very much useful for all the participants. They get to understand what is basically happening. Okay, so I'm thankful to all of you and the administration. Secondly, I would like to say sorry to all the participants, because the kind of scenario we have seen during the webinar, it is a learning to me also, that how to improve and how to be cautious about such kind of hindrance during the session, like electricity is gone or internet is gone, something like that. And thirdly, you see, the such kind of problems when come, we don't think that, because in our times we used to think that अरे आज तो मजा आ गया, आज हमने जब किया तो अरे वो तो उसका तो टॉक, जो जिसने टॉक दिया दैट एक्सपर्ट का तो इंटरनेट ही चला गया. Don't think in that way, है ना. See this problem and work upon this problem also. This is a very big problem that we are facing. Okay, 24 cross 7 electricity, that is also one of the problem, and people are working on smart grid. So you may go and think about that problem, read about the problem statement, and come up with solution for that, if it is your area of research and if you want to embark into. Thank you, and thank you very much all the participants and the administration and computer engineering department of SNPIT and RC. Thank you very much.
Thank you, sir.